All right, today I'm going to be talking to you a little bit about gangliosides and how they apply in neuro-ophthalmology. You don't have to know everything about ganglioside, but you need to know what it is and how it can relate to downstream autoimmune disease through a process called molecular mimicry. And molecular mimicry comes up a lot in terms of autoimmune conditions in neurop that are precipitated by infectious diseases as a trigger. And so just very briefly, what we're trying to do in terms of making the ganglioside or the cerebroside or the globoside is get to the core molecules. And these two core molecules are extremely important because they have multiple functions across multiple cellular interactions, both cell signaling and membrane formation and the immune response. And so when you make sphingosine, you're really starting off with amino acids like serine and palmitoyl-CoA, and then through a series of redox reactions, you get to this core molecule. When you convert that to the waxy ester, that's the ceramide, and the ceramide is what's going to end up being the backbone of the sides. And they're called sides because we're adding something onto the side. A series of sugars is going to be added onto here. And if you have just a glucose or a galactose, a single sugar, that ceramide plus that single sugar is what we call a cerebroside. So it'd be a glucose cerebroside or a galactose cerebroside. However, if you add a neutral sugar on there like GalNAc, that's a globoside, but the one we're talking about today is ganglioside. And what makes a ganglioside is the addition of an oligosaccharide chain, and that's formed by N-acetyl-neurominic acid. And it just takes too long to say that, so we just call it sialic. And you remember our old friend sialic acid because the sialic acid is also the thing on the red cell membrane that produces the negative zeta potential that allows the sedimentation rate to be a measure of inflammatory disease. And it's the same thing, sialic acid, nana. So if we have one of these nanas, that is a ganglioside because we have the ceramide core, the associated sugars in a certain sequence, in this case these 4 sugars lined up, and one little triangle, and that triangle equals nana. And if we have 2 of these guys, that's going to be ganglioside di-sialic acid. If we have 3 of these guys, that's going to be ganglioside tri-sialic acid. And if we have 4 of these guys, that is ganglioside quattro. And because the core backbone has this configuration here, that's going to be a number 1 configuration. If we lop off this one, that's going to be making it a bigger number. So each time we take off one of these core sugars, we're going to be reducing it from a 1, a 2, and a 3. So this happens to be a 1 because it has all the sugars in the backbone. And because we have 4 sialic acids, that's a quattro. And then we have 2 series, which are basically rows, the A row and the B row. So for example, in this example, we have ceramide, the core sugar backbone, that's ganglioside. We got 4 sialic acids, that's quattro. We got the 1 configuration, and we have the B series, and that's going to characterize GQ1B. And the reason you need to know about GQ1B is this same configuration is highly conserved, and so bacteria use the same configuration by accident in their glycoprotein coats, in their lipopolysaccharide coat. And the one that causes the cross reaction, the molecular mimicry, is Campylobacter jejuni. So it just so happens that the Campylobacter jejunis lipopolysaccharide look very similar to the ganglioside. And so when we're testing for diseases where people have autoimmune molecular mimicry after Campylobacter jejuni diarrhea, they might get Guillain-Barré syndrome, the Miller-Fisher variant, and you can watch the video on those 2 conditions. But this piece of it is what's causing the molecular mimicry. So you don't need to know everything about gangliosides, but you do need to know the core molecules, sphingosine, ceramide, how we add the sugars, make the sides, and how that side might look exactly like Campylobacter jejuni.